Augmented matrices and row echelon form are important concepts to understand if you want to work with matrices. So we're going to explain them right now. Welcome to Math Bytes. I'm Allison, and today we're talking about augmented matrices and row echelon form. We can create a matrix from a system of linear equations. So for example, I have a system of linear equations here, and we can write a matrix using the coefficients and constants. So here's my matrix. Now you'll notice if I look across the top row, that corresponds to the first equation in my system of linear equations. And if I look across the second row, that corresponds to the second equation. Now notice in that second equation, we don't have a z term, so I had to put a 0 in that position in the matrix. And if we look at the third row of our matrix, that corresponds to the third equation in our system of linear equations. This is the augmented matrix of the system of equations. Now, we can split this into two matrices. We can split it into the matrix of just the coefficients, which is called the coefficient matrix, and the matrix of the constants, which is called the constant matrix. A matrix is in row echelon form if the first non-zero element in any row, which is called the leading entry, is 1. Each leading entry is in a column to the left of the leading entry in the next row. And any rows with all 0 elements are at the bottom of the matrix. Now, these conditions are a lot easier to understand when you look at examples. So let's look at some examples. These three matrices are in row echelon form. Now, if we look across any row, the first non-zero number we see is a 1. That's the first condition. The leading entry in the first row is to the left of the leading entry in the next row. And in matrix C, the leading entry in the second row is to the left of the leading entry in the third row. That's the second condition. Matrix A is the only one with a row of all 0 elements, and that row is at the bottom of the matrix. That's the third condition. Understanding augmented matrices and row echelon form are essential for using the Gaussian elimination method. That's using matrices to solve systems of linear equations. That's it for this episode of Math Bytes. If you like our videos, please subscribe to our channel. And if there's something you'd like to ask us, just send us an email. We're at contactmathbytes@gmail.com, and we'll see you next time.